Solving logarithmic and exponential equations. So the first thing, I have both these first problems listed. Before you solve any of these, always look to make sure you understand what the domain is for your possible answers. So we have, one variable right here, it's x, and we know with logarithms, whether it be base 5, whatever it happens to be, natural log like in part B, whatever it is, these, when we evaluate values that go right here in this spot on our logarithm, where the x is right here, have to be greater than 0. So that means that whatever answers we get have to be greater than 0 on this particular problem. So now we just always keep that in mind. So always look at your what your domain of answers can be. So you could say, log base 5 of x squared, for instance, move that 2, right, as an exponent. And then we have log base 5 equals 9. And then remember last time's notes, I said you could raise 5 to this power, or 5 to log base 5 of 9 is equal to x squared. And you talked about those properties and how they quote unquote cancel. So basically, since they both have log base 5 on both sides, a shortcut's just to say we can drop the logs. So now we're left with x squared equals 9. So if you were solving this equation, that means x could be 3 or negative 3. But as we stated before, x has to be greater than 0. So negative 3 is an extraneous solution. So x equals 3 would be our only answer to that problem. You can plug it in and check it, obviously, as well. All right, part B. Natural logs. Well, our logarithm properties tell us that if you're adding, remember you can bring those together now and make it multiplication. Let's figure out the ln of x plus 6 on the right over there. I think you can see it on the screen, barely. So now we've brought everything in together as one natural log and one natural log on the left, one natural log on the right. We can drop those natural logs, just like we did on the first problem. So now it's x times x minus 4 is equal to x plus 6. So now it's just a matter of working this problem out. So you could have, x squared minus 4x is equal to x plus 6. Get everything to one side. X squared minus 5x minus 6 is equal to 0. We can factor that as x minus 6 and x plus 1. So it looks like we have two possible answers of 6 or negative 1. Now, just like I said before, and I think it's a good idea, I didn't do it on this problem, but you can probably sit here and say, well, there's two answers. But remember, before you answer, one or both for that matter, always go back and make sure that you understand what your domain is for the problem. So for this ln of x, as long as x is greater than 0, it would be okay for the ln of x. We're talking about our original equation right at the very beginning. For right here, in order for this to be greater than 0, x would have to be greater than 4. Okay, and then this last one for ln of x plus 6, as long as x is greater than negative 6, we're in good shape. I don't know if I can get that on the screen. Let me try to kind of fold my paper a little bit. So there's our choices there. So x is be greater than 0, greater than 4, greater than negative 6. Well, basically, you're just sitting here saying, well, if x has to be greater than 4, this is probably the one that we're going to focus in on, because x greater than negative 6, you can plug in negative numbers, obviously bigger than negative 6, that would not work for these other two. So you're just looking for the one that works for all of them. So basically, you're looking for the x values that work for all of these. So like and, not ors, for all of them. So we're looking for all the values that are x is greater than 4. So we look down here at our bottom. That means that negative 1 does not work for x is greater than 4. But our 6 does. 6 works for all of these. And remember, the only one you're really concerned about is the larger number. So x equals 6 is our only solution to part B. Part 2, answer choice, or part A. So here's section 2, part A. We have log base 5 x plus 6 plus log base 5 x plus 2 equals 1. So looking at our domain, we know that our answers have to be greater than negative 6 for that part. And then x has to be greater than negative 2 for that logarithm. So the one we're going to focus in on is obviously just this x is greater than negative 2 for our possible domain of answers. So this is an addition again. So remember, the same exact thing as writing it as log base 5 of x plus 6 times x plus 2. And that's all equal to 1. So now we're going to use our normal logarithm definition. 5 to the first is equal to x plus 6 times x plus 2. So we know that's x squared plus 8x plus 12 after we expand it. So it looks like we're going to be equal to x squared plus 8x plus 7. That factors x plus 1 and x plus 7. So we have two answers. X could be -1 or -7. And the only one that's greater than -2 is the -1. So -7 is our extraneous solution. All right, our next problem. This one requires a calculator. X has to be greater than 0. X has to be greater than -2. So it looks like we're going to focus in on all of our answers that are greater than 0. Using our logarithm properties, this would be ln of x times x plus 2 is equal to 4. Remember, this is base e, so this would be e to the 4th is equal to x times x plus 2. Go ahead and expand, and then we'll get this isolated to one side so that we have 0. It looks like it's going to be a quadratic, so that'd be x squared plus 2x minus e to the 4th. This is not a problem that we can factor. You could go about it with quadratic formula if you wanted. You can graph it and look for points of intersection, or zeros for that matter. And there's going to be 2 zeros if you were to graph it and look for the answers, but we want the one that's greater than 0. Just to kind of save us a little bit. X would be 6.456. And that's 3 decimal places, truncated or rounded. The other answer is negative, which is obviously not the one that's greater than 0. So there's our answer on that problem. All right, here's part 3. Letter A. This looks like exactly like the ones we did in our previous notes, at least this first one. 5 to the x squared plus 8. Remember, we could write 125 as 5 cubed. That's to the 2x power. So we're saying that 5 to the x squared plus 8 is equal to 5 to the 6x. We're going to multiply those. So essentially we're saying when or what value of x will yield x squared plus 8 and 6x to be equal. Well, we isolate it over, set equals 0. This would factor is x minus 2 and x minus 4. So we have 2 possible answers here. X could be 2 or 4. And if you were to go back and plug them in, you would notice that both answer choices work. So we have 2 answers on that problem. All right, so our next one. E to the 4th raised to the x power times e to the x squared equals 12. So this is e to the 4x times e to x squared. It's equal to e to the 12th. So if we take these common bases, remember we would add them. So that'd be, I'm just going to rewrite it as x squared plus 4x is equal to e to the 12th. So now we can just focus in on the exponents. So when is x squared plus 4x equal to 12? So we have another quadratic that we're solving here. Set equals 0. Hopefully it factors. Which it looks like it's going to be x plus 6 and x minus 2. So it looks like our answers are -6 or +2. And as always, it's always a good idea to kind of go back and plug them in and check them. And I believe both of these do work. So we're going to have 2 answers of -6 or 2. Okay, section 4, part A. These are a little bit different because the bases are not the same. I'm going to show this problem 2 different ways. You just do the way that you feel most comfortable with. All right, so first thing, we could take 3 to the x and isolate it by dividing the 8 over. So now we have 3 to the x is equal to 5/8. We don't really know what power of 3 to what power would give us 5/8, so we're going to apply a logarithm on both sides. So we can say log of 3 to the x, log of 5/8. So now we could take our x, we could divide it over. Or I'm sorry, we could take our x and move it to the front. So x log of 3 is equal to log of 5/8. So now we want to take this x and isolate it. So we'll say that x is equal to log of 5/8 over log of 3. And then using our change of base, or we can write that just as one logarithm. So this would be log base 3 of 5/8. So just kind of going in the other direction. So that's one way of going about and solving it. Another way is, I'm going to go back to this first step that we did earlier after we divided by 8. And we know that 3 to the x is equal to 5/8. So remember, with logarithms, log of some base, we'll call it b, if you're evaluating if x is equal to y. Some of you might like this way as well. Either one works for me, like I said. So another way of thinking about it is, well, this would be b to the y is equal to the x. So our b would be the 3 this time, right? Because that's where the 3 would be located if we went and made this b to the y is equal to the x. The y is our exponent, right? It's our x. I probably should say a and b up here. If I make things a little easier, or we'll call it a and c. Let's make this a little clearer. Sorry, guys. So make sure I'm not confusing you with all these different variables. So we'll say log base b of a and c. So remember, b to the c is equal to a. So basically, I'm just trying to make this part, translating it back into a logarithm. So remember, the b right here is our 3. So that's where the log of the b would go. The x is our c, which is what it's equal to. And the 5/8 right here is our a, which is where it goes in this logarithm right there. So our 5/8 needs to go right there where the log is. Hopefully I didn't confuse you there. And you can see, of course, that these two answers, they match. Okay, our next one, e to the x plus 3 equals pi to the x. One thing I'm going to do in this problem, you notice that we can't get a common base once again, so we're going to have to incorporate logarithms. On the previous problem, when I was solving it this way, notice I went to logs. We could have any base we wanted. On this one, I'm going to go to natural log because I see an e. We know that if we have an ln and an e, sometimes that makes things easier because that might produce a 1 for us. So I'm going to apply natural log of e to the x plus 3 equal to natural log of pi to the x. So we can move those x plus 3 and the x in front. Well, here it is. Ln of e we know is 1. So this entire set of parentheses right here is a 1. So basically we just have x plus 3 times 1, or x plus 3, is equal to x times ln of pi. There's several ways to go about it here. Maybe you just want to take the x on this left and subtract it over to the right side of the equation. And then we know that we could factor out an x, leaving us with ln of pi minus 1. Divide that ln of pi minus 1 over, and we're going to have 3 over ln of pi minus 1 is equal to x. And there's our answer. And remember, you could have negatives in different spots. For instance, if you had, moved the x ln of pi over and a 3 over, you'd have negatives. So these negatives could be changed over, but they're all equivalent answers. All right, solving exponentials in a quadratic form. First thing we notice is that we could take 4 and 2, and we notice that they can have a common base if you change this 4 into 2 squared. So this is the same thing as 2 squared to the x minus 2 to the x minus 12. Well, that'd be the same thing as 2 to the 2x minus 2 to the x minus 12. I'm going to rewrite this a little bit. And we're going to say now it's 2 to the x squared. So we just take basically went from this step to here. I just want to make sure I incorporated this next line in so it didn't confuse you. But you can see that x and 2 multiplied together would give us 2x. And from here, we have a quadratic. And if you recognize it that way and you want to work with it as with 2x's or 2 to the x powers, you're more than welcome to. Just for teaching purposes and to make it look a little cleaner for us, I'm going to let u equal 2 to the x. So just to rewrite this, this would be no longer 2 to the x power, but u. So this would be u squared minus u minus 12 is equal to 0. And that probably looks a lot easier as far as factoring is concerned. We know we're just going to have our u's. What's that going to be? Probably a minus 4 and a plus 3. So the factor is u minus 4 and u plus 3. So we're saying when is u minus 4 equal to 0 and when is u plus 3 equal to 0? And this is the moment where we want to probably go ahead and put our 2x, 2 to the x power back in. So we're looking at 2 to the x power minus 4 and 2 to the x plus 3 equal to 0. We're saying when is 2 to the x equal to 4? Well, that's when x is 2. And when is 2 to the x, if you didn't see it, when is 2 to the x equal to negative 3, notice we can't raise 2 to any power and get a negative. So that's going to be an answer that is not included. So we have 2 is our only answer for that problem. All right, part B. We could rewrite this as 3 squared to the x minus 3 to the x plus 1 plus 2 is equal to 0. Sorry, it's really sloppy. 3 squared. So basically, just like we did earlier, this becomes 3 to the x squared. And then this one, the minus 3 to the x plus 1, it's not really focusing very well. Apologize for that. I'm going to rewrite this as, let's do it 3 to the x times 3 to the first. Obviously, if you combine these, you would add the exponents. And I'm going to go one more step just to make sure that this is clear, hopefully. I'll rewrite this 3 to the first and put it in the front times 3 to the x. Once again, plus 2 is equal to 0. This is where we're going to put our u value in. So let's let u equal 3 to the x. So we're going to have x squared minus 3, well, 3 to the x is u, so 3u plus 2 is equal to 0. Well, that factors, I'm sorry, u squared. I apologize. U squared. Remember, u is equal to 3x. So there we go. U squared minus 3u plus 2. So that factors with u minus 1 and u minus 2 equals 0. So now we're going to split it up. U minus 1 equals 0 and u minus 2 equals 0. And there's a lot of different ways we can go from here. We could go ahead and just put our 3x in. So 3 to the x minus 1 equals 0. 3 to the x minus 2 is equal to 0. So this first one's nice. Add your 1 over. So when x is 0, that'd be one of our solutions. Now we're looking at this other one. 3 to the x is equal to 2. Well, that one's, remember one of those problems that doesn't have a same base. So I'm going to show it 2 ways again, just especially for notes purposes at least. So here's 3 to the x equals 2. One way we could do it, remember, is to apply logarithms. So we can say log of 3 to the x equals log of 2. So x log of 3 equals log of 2. Therefore, x is log of 2 over log of 3, which when we do a change of base is just log base 3 of 2. So there's our 2 answers. X equals 0 and log base 3 equals 2. All right, and just to show this problem, another way of solving that, which I've already done, but I want to make sure that I show it once, just show it again. Remember, if we had a logarithm of some base b evaluating a, and we had equal to c, that b to the c power is equal to a. We talked about that already in previous notes. So our b in this case is a 3. So we want to rewrite it. That's just logarithm. The b is our 3. The c right here, the exponent, is what it's equal to. Our exponent in this problem is x. And the a is we're evaluating that logarithm at that spot. So that's the 2 in this problem, right? You can see they match, which is the exact same answer as what we got earlier. So we have 2 solutions on this problem. All right, we do have one problem another problem that's requiring a calculator. If you had x plus e to the x equals 2, and you're looking for just a decimal answer, obviously we could just put this in a calculator and solve. So we could just put y1 equal to x plus e to the x. And let's let y2 equal the other side of the equation 2. And then you would look just for that point of intersection, which would be 0.443. And we're just going to 3 decimal places. 2. So that'd be our intersection point. And if it asks, what x value, then obviously you would just give the 0.443. All right, our last part, mixed practice. So if you're given f of x and g of x, and we say that f of x is equal to 3, obviously what is x equal in this problem, and what point is that on the graph? So let's let f of x equals 3. So 3 is log base 2 of x plus 3. All right, so that means that we know that 2 to the 3rd power is equal to x plus 3, or 8 is equal to x plus 3. So x is 5. And then it followed that up with what point would that be on the graph? Well, that would be the point 5, comma, and we said that y is equal to 3, or f of x is equal to 3, so 5, comma 3. All right, part B. Now we're going to let g of x equal 4. All right, so we know that 4 is equal to log base 2 of 3x plus 1. So 2 to the 4th power is equal to 3x plus 1. 2 to the 4th is 16. Subtract our 1 over and divide by 3. We get x equals 5. So that would be the point 5, comma, remember g of x is 4, so 5, comma 4 would be the point for part B. All right, part C is a system. Basically, what we're saying is where are logarithms equal? Where's f of x equal g of x? So where's log base 2 of x plus 3 equal to our other one, g of x, log base 2 of 3x plus 1. And remember, we're looking for a point of intersection here. This is where 2 equations are equal. I'm not sure why it's not focusing now. I apologize for that. Hopefully my words are good enough. Remember, we can drop the logs now because of the same. So it's just x plus 3 and 3x plus 1. And if we were to solve this equation, you can subtract your x over, subtract your 1 over here, so that'd be 2 equals 2x. So x equals 1. But we're looking for a point of intersection, so we have our x value. Now we need to find our y. So we need to plug 1 back into either the f of x or the g of x. So let's just say I chose f of x. So we're saying f of 1, well, that would be equal to log base 2 of 1 plus 3. So we're saying log base 2 of 4, which means that 2 to the 2nd power would give us 4. So that would be 2. So we have our point of intersection is 1, comma 2 for part C. All right, part D. We're adding f and g, right? So that would just be the same thing as saying log base 2 of x plus 3 plus log base 2 of 3x plus 1 equals 7. So it's going back to when we're doing at the very beginning. You need to be careful of our domain. X has to be greater than -3 for that part. X has to be greater than -1/3. So basically our answers need to be greater than -1/3. That's not showing up very well. Need to be greater than -1/3. That didn't help. All right, so log base 2. We have x plus 3 and 3x plus 1 multiplied together. Because remember, when we're adding logs, we can bring them together as one product. Is equal to 7. So we're going to have 2 to the 7th. It's equal to x plus 3 times 3x plus 1. I'm going to go ahead and expand that. So 3x squared, what would that be, plus x plus 10x plus 3. 2 to the 7th is 128 equals 3x squared plus 10x plus 3. So we'll get that equal to 0. Subtract your 120 over, so it'd be negative 125. Let me rewrite that, sorry. So 3x squared plus 10x minus 125. Now we're looking to factor this, if we can. So now we have a 3x and we have an x. So we're just looking to see what we can multiply here to get these. We know 25 and 5 would give us 125. It looks like if we were to go plus 25 minus 5, because this would give us 25x and that would give us negative 15x. So yeah, that'd work. 25 minus 15 would give us our 10x, and opposite 25 times negative 5 is negative 125. So when is 3x plus 25 equal to 0? When is x minus 5 equal to 0? Well, that's when x is negative 25/3, or when x is 5. If you remember, we want x to be greater than negative 1/3 based on our domain here at the beginning. Well, negative 25/3 is too big, or too small rather. So x equals 5 is our only solution on that problem. Last problem. Now we're going to subtract them. Log base 2 of x plus 3 minus log base 2 of 3x plus 1. And we're going to set that equal to 2. So we can bring those logs together. Log base 2, when subtraction, remember, we can bring them together as one division. So 3x plus 1, x plus 3 is equal to 2. So 2 to the 2nd is equal to x plus 3 over 3x plus 1. Well, that's 4, right? So it would just be 4 is equal to x plus 3 over 3x plus 1. Multiply that over. So we have 12x plus 4 is equal to x plus 3. So it looks like we're going to have 11x is equal to negative 1. X must be negative 1 over 11. Looking back at our problem, remember x needs to be greater than negative 1/3. Same exact stipulations. Remember, this has to be, this part needs to be greater than negative 3. This has to be greater than negative 1/3. And negative 1/11 is greater than negative 1/3. It's less negative, you could say, I guess. So x equals -1/11. As always, if you have questions, let me know. Stay out of the trees.